Welcome, Ichak Solution. This is Modulus Inequality Part 2. We are continuing from the previous lesson. Alright, so we said in the previous lesson to solve modulus inequalities, number one, you solve the corresponding modulus equation to find the critical values. Then number two, you arrange the critical values using the inequality boundaries or region. Then number three, you test the boundary to see the true region here. So these are the concepts that will be main focus on here. Alright, so let's go to this one. Solve the inequality modulus of x plus 3 greater than or equals to modulus of 2x plus 2 here. So let's go here. So the first thing is to find the critical values. So to find the critical values, we solve the corresponding modulus equation here. So the corresponding modulus equation is modulus of x plus 3 is equals to 2x plus 2 here. So what we are going to do here, we know that the absolute value of 2x plus 2 here can be equals to plus or minus this value. So we're going to write x plus 3 is equals to plus or minus 2x plus 2 here. Right, so now we can derive two equations here. So we're going to have x plus 3 is equals to 2x plus 2. So x is equals to 1 for the first equation. Another equation that we can have x plus 3. Then we take the one with a minus here. So we place minus, we're going to have minus 2x minus 2. So if so for x here, we're going to have 3x is equals to minus 5x. Then x is equals to minus 5 over 3. So we now have the two critical values that we have here. So the next thing is to place these critical values on the table using the inequality boundary so that we can test them here. So we are starting with the smallest one. So it's x less than minus 5 over 3, which is the smallest critical values. Then minus 5 over 3 less than x less than 1 here. Then we go to the last one is x greater than 1 here. So you can see the smallest one is x less than minus 5 over 3. So it's less than, for the smallest is less than. Then for the greatest critical value is x greater than 1. Then in between here we'll be joining the critical values here. So now we are testing these critical values. So we're going to test them using this inequality here. So we'll be testing whether this first region is true or false, and the second region here is true or false, and the third region here is true or false by testing whether the region will satisfy this inequality. Alright, so we are testing for x less than minus 5 over 3. So we just look for a number which is less than minus 5 over 3. So that number will be x equals to minus 2 here. So we can use minus 2, we can use minus 3, we can use any number that is less than minus 5 over 3 here. So we use minus 2 in this case. Then we place minus 2 here. We're going to have minus 2 plus 3 greater than or equals to 2 times minus 2 plus 2 here. So this will give us 1 is greater than or equals to modulus of negative 2. So actually we are going to have 1 greater than or equals to 2 here. So this negative will just be swallowed by the absolute value. So which means 1 will be greater than or equals to what? Equals to 2. So 1 greater than or equals to 2 is a false statement. It's not a true statement. 1 is not greater than 2. So which makes this region to be what? To be a false region. Alright, then we go to the next one, testing for minus 5 over 3 less than x less than 1. So we are looking for the number between minus 5 over 3 up to 1 here. So we are using x is equals to 0. So we are going to place 0 on both sides of this inequality here. So we are going to have 0 plus 3 greater than or equals to 2 times 0 plus 2 here, which is going to give us modulus of 3 greater than or equals to 2 here. So you can see 3 is greater than 2 here. So this is a true statement. So 3 is greater than 2. So it's true. So which makes the middle region here to be what? To be true here. Right, so now we test the last region here, x greater than 1 here. So testing for x greater than 1, we are going to use any number that is greater than 1. We can use x equals to 2. So we can have 2 plus 3 greater than or equals to 2 times 2 plus 2 here, which is going to give us modulus of 5 greater than or equals to 6. So 5 is greater than or equals to 6. It's a false statement. 5 is not greater than or equals to 6 here. So which makes the last region to be a false region here. So therefore our solution will be the true region here, which is minus 5 over 3 less than x less than 1 here. So we are taking this region. So let's go to the next example here. Alright, so solve the inequality modulus of x minus 3 or over 3x plus 1 less than 2 here. So you can see we have this fraction which is under the modulus here. So we just need to explain something here. Alright, so if you look here, if we have a situation where we have f of x over g of x which is under the modulus here, so you can separate it to become modulus of f of x over modulus of g of x here. Alright, so in the left hand side we can have modulus of x minus 3 over 3x plus 1, which is equals to modulus of x minus 3 or over 3x plus 1 here under the modulus. Alright, so the modulus can be on the top, the numerator, then also the modulus can be on the denominator here. So now the next thing, we can cross multiply. We can multiply here with modulus of 3x plus 1 to the side of 2 here. Since modulus of 3x plus 1 is always a positive, it's not going to be a negative. So you can cross multiply. It is not going to affect the inequality sign. Remember, when you multiply with a negative number or divide with a negative value on the inequality, it will affect the inequality sign by reversing it. So in this case, we are just going to be multiplying with modulus of 3x plus 1 on the other side here, since modulus of 3x plus 1 is always a positive. So it's x modulus of x minus 3 less than 2 times modulus of 3x plus 1 here. Right, so now we can multiply with 2 inside of this modulus. So you're going to have modulus of x minus 3 less than 6x plus 2 here. So the next thing now, we can find the critical values. So finding the critical values here, we are going to find the corresponding quadratic corresponding modulus equation. So which is modulus of x minus 3 is equals to modulus of cx plus 2 here. So we want to find the solution to this equation here, which is a modulus equation. Alright, so it's x minus 3 is equals to plus or minus 6x plus 2 here. Alright, so now you can also place plus or minus on the left hand side. We will just have the same result here. Alright, so in this case we are going to have x minus 3 is equals to 6x plus 2 here by taking the one with the plus here. So this will give us minus 5x is equals to 5. So x is equals to minus 1 here. That's your first critical value here. Then we go for the next one. We have x minus 3 equals to minus. So we put a minus here. So it's going to be x minus 3 is equals to minus 6x minus 2. The minus will affect inside the bracket here. Then we solve. We are going to have x is equals to 1 over 7 as your critical values. So the next thing is to test these critical values on the table here. Alright, so we are testing here. So it's x less than minus 1 is your smallest critical value. Then minus 1 less than x less than 1 over 7. Then we have x greater than 1 over 7 here. Alright, so now we are testing these critical values here using this inequality of x modulus of x minus 3 over 3x plus 1 here less than 2. So the first region that we are going to test, we are testing for x less than minus 1. So we are going to use any number that is less than minus 1 here. So the number that is less than minus 1 here is x is equals to minus 2. So we substitute it into the inequality here. So it's going to be modulus of 1 less than 2 here. So 1 is less than 2, which makes this statement to be true, since 1 is less than what? Was less than 2 here. So the region of x less than minus 1 is a true region. So this is a wanted region that we want. Then we go for the next region here. Is minus 1 less than x less than 1 over 7. So we are going to use x is equals to 0 here. A number between minus 1 to 1 over 7, we can use 0. So we substitute 0. We are going to have modulus of minus 3 is less than 2 here, which is going to give us 3 less than 2 here, because the negative here under the absolute value will disappear. So 3 is less than 2. So 3 is less than 2 is false. 3 is not less than what? 2. So this is false. So this makes the middle region to be a false region here. Then we go to the next one. We are testing for x greater than 1 over 7. So we are going to use any number that is greater than 1 over 7. We can use 1. Right, so we are going to have 1 minus 3 over 3 times 1 plus 2 less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less than 2 here. So this will give us minus half under the modular less t So the absolute value of minus half is half here. So half is less than true. It's true. Half is less than 2 here. So it's a true statement here. So which makes the last region to be true here. So therefore, the set of solution will be x less than minus 1 union x greater than 1/7.